welcome to the deep dive.
Yeah.
Today we're tackling something that looks pretty simple on the surface. Scaffolds.
Yeah, exactly.
But trust me, digging into these safety training materials, well, it reveals a surprisingly complex and really critical world. We're talking engineering, safety, the whole deal. So our mission today is to kind of pull out the key principles, look at the different types, and basically give you a clear, concise rundown of what keeps these temporary work platforms safe.
It really is remarkable, isn't it, how much planning goes into something that's, designed to be temporary.
Right.
And these training docs, they really hammer home that a scaffold, especially the modern metal ones, it's not just a structure. It's a whole system, carefully engineered.
Yeah, a system where every single piece matters for safety at height.
Precisely.
And the system, according to what we've read, it comes with some serious potential dangers if things aren't right.
Oh, absolutely.
We're talking, falling tools, parts falling during construction even.
Yeah, and the erectors themselves falling.
That too. And then scaffold collapse, either during construction or later during use.
Plus materials falling while people are actually working up there.
And of course the big one, workers falling from the platform itself.
Yeah, that's always the major concern.
So when you look at why these accidents happen, the materials suggest it's rarely just like random bad luck.
No, not usually. It often comes down to a few core things. You've got defects in the materials themselves, cracks, rust, even wood getting wet or too dry.
Right, material integrity.
Then there are design flaws. Maybe the base isn't right, or the supports, the ties holding it to the building, even the width of the platform, or how people get on and off.
Makes sense. And misuse seems like a big one too.
Huge. Things like overloading it, putting way too much weight on it.
Or just using it incorrectly, maybe dropping items.
Exactly. Even moving heavy loads on the scaffold itself can be risky. Oh, and people tampering with it, taking bits off.
Unauthorized modifications. Bad idea.
Very bad. Plus, just not controlling materials and tools properly up there. Or, trying to climb up while carrying stuff.
So many potential pitfalls. Okay, thinking about these risks, what are the main types of scaffolds then? The training mentions frame scaffolds first. Those seem like the common ones.
Yeah, those are the ones you see a lot. Pretty easy to assemble, good for various jobs, but they really need a level surface. Base plates, pins, frames, crosses, the platforms.
Gotcha. Then there are tube and clamp scaffolds. These sound more complex.
They are. They're for more intricate designs or when the ground's uneven. Super adaptable, but you definitely need skilled technicians, often engineers involved too. It's all tubes, clamps, base plates.
So frame is like the standard kit, tube and clamp is more custom built.
Kind of, yeah. Tube and clamp gives you that flexibility for really tricky situations.
Okay. Then we have modular and cup lock scaffolds mentioned. Both sound heavy-duty, easy assembly.
Right. Described that way. Modular is multi-directional. Cup lock is 4-directional. Good for heavy loads, quick setup.
And then the ones on wheels rolling and mobile scaffolds.
Yep. Rolling are usually those prefab aluminum ones. Good for light work, indoors, hard surfaces are key. And the brakes on those wheels, absolutely essential.
And there's a height limit, right?
Yeah.
3.5 times the narrowest base dimension.
Yeah.
And you can't tie them off.
Exactly. Same goes for mobile scaffolds, which could be any type, just put on wheels. Same rules apply. Hard surface, brakes, height limit, no tying.
Finally, suspended scaffolds, the cradles hanging by wires. These sound like they have super strict rules.
Oh, definitely. The safety factors are much higher, like 4.1 for the scaffold structure itself, but 6.1 for the wires and connections.
Wow.
Yeah. And counterweights need careful calculation. Plus, crucially, workers must be tied off independently with a harness to a separate anchor point. It's a vital backup.
Makes total sense. Okay, so across all these different types, what are the absolute non-negotiables, the safety must-dos?
Well, number one, use sound components. No defects, no hidden flaws, everything's got to be in good shape.
And that low capacity thing you mentioned, 4 times the total load.
Yes. 4 times the dead load the scaffold itself, plus the live load people, tools, materials, plus any environmental load like wind or rain. It's a big safety margin.
That's huge. So planning is critical too. Inspecting the site first.
Absolutely. You need a plan based on the work in the site conditions, and never ever use random bits of wood or bricks to level the base. Only proper wooden planks if you need to distribute the load.
Right, and safe access getting on and off safely.
Crucial. Fixed ladders are preferred if you're going higher than about 3.65 meters, with landings every 9 meters. If you use a portable ladder, it needs to extend 90 centimeters above the platform.
In tying off the scaffold itself, when is that required?
Once it gets taller than 4 times its smallest base dimension, then you need ties.
Yeah.
Max 9 meters apart horizontally, 8 meters vertically. OSHA actually requires 50% of those to be positive ties, like box ties or through ties.
Okay, and simple stuff too, like not storing materials up there.
Yeah, keep the platform clear. And stay away from power lines. Minimum 3 meters from high voltage lines, more for higher voltages.
Good points. Let's quickly touch on some key components. Guardrails, they enclose the platform, right?
Yep. Need top rails, mid rails, and toe boards or brick guards to stop stuff falling. They have to be strong, withstand specific forces, like 200 pounds on the top rail.
Okay.
Yeah.
And smooth, no sharp edges, securely fixed.
Exactly. Made of sound material, specific heights too, top rail around 1.10 meters, mid rail about half that.
And the bases we mentioned need those proper supporting planks underneath.
Extending out at least 23 centimeters on each side.
Bracing, too, stops it swaying.
Right. Diagonal bracing is key for stability, prevents movement and vibration.
And the ties we mentioned connecting it to the building.
Yeah.
Required above that 4x base dimension height.
Yep. Reveal ties, box ties, through ties, different ways to secure it properly.
And the platform itself, the planks people walk on. Specific requirements there, too.
Oh, yeah. Usually 2-inch thick, 10-inch wide planks. Minimal gaps between them, ideally none. Minimum platform width is 18 inches overall.
And how they overlap.
If planks aren't fixed, the overhang should be between 6 and 12 inches. And where planks join end to end, they need to overlap by at least 12 inches, usually over a support.
Lots of details. Okay, quickly on load capacity. You mentioned light, medium, heavy duty.
Right. Light duty is rated for about 25 pounds per square foot, medium for 50, heavy for 75. There are even height limits based on duty, like frame scaffolds for light duty typically max out around 33 meters.
And that total load calculation included dead weight, live weight, and environmental load.
Correct. Dead is the scaffold structure. Live is people and gear. Environmental is wind, rain, snow sometimes.
Got it. Lastly, the training briefly covers ladders and stairways for access. Important too.
Very. Falls, slips, even electrical contact are hazards with ladders. Basic rules. 3 points of contact always. Stable base. Proper angle, that 4.1 ratio.
Secure it, don't overreach.
Right. Use insulated ladders near electricity. If you have 25 or more workers, you need specific ladder provisions. Step spacing matters. Don't use the top rungs.
And fixed ladders over a certain height need cages or fall arrest systems.
Yeah, over 7.3 meters. Landings needed to, every 15.2 meters or so.
Stairways also have rules, handrails, landing sizes, angle.
Handrails usually needed for 3-4 steps, or if it's over 76 centimeters high. Landings every 3.7 meters of vertical rise, specific dimensions, angle between 30-50 degrees.
So wrapping this up, the main takeaway from this deep dive seems clear. Scaffolds might look simple and temporary, but they are genuinely complex systems.
Absolutely. They demand really careful planning, using the right sound components, and strictly following all those safety rules to prevent some potentially horrific accidents.
It really makes you think, doesn't it? Considering how temporary scaffolds are, what other temporary things in our lives, structures, or setups maybe deserve that same level of really rigorous safety thought and planning?
That's a great question to ponder. Where else do we encounter temporary setups that could benefit from this kind of detailed attention? Something to think about.